So now we need to plug it into the equation. And this is the fun part. And long part. So let's start with plugging into the equation. Let's start with the first one up in the right hand top corner. And when we look at this chi-square, we're looking at the summation of it all. So we're taking the observed, right? The observed 67 minus the expected 117.9, square it, and divide it by the 117.9. Okay? So now you have this piece, right? That's only one piece to the problem. Now you have to add, because this is a summation problem, remember? We got to add each piece to this problem. So you go directly to the left of it, or to the right of it, and that's the observed 213. And the observed 213, I'm going to put in a different color. 213, right, minus the expected value, which is 191.2, squared minus 191.2, okay?
Divided by.
Oh, sorry. Divided by 191.2, okay? And then add the next piece. And we're going to continue adding all the pieces. So now the next one is 74 minus 44.9 divided by, squared, divided by 44.9, okay? And then we're going to add on to that, okay? And we're going to do that all the way down the line. So now we have go with some colors that are bright. So we got 411 minus 390.6 squared divided by 390.6, okay, plus 633 minus 633.5, is that right? Squared divided by 633.5. Okay? And then we got plus 129 minus 148.9 squared divided by 148.9 plus 85 minus 47.6 squared divided by 47.6 plus 51 minus 77.2 squared divided by 77.2 plus 7 minus 18.2 squared divided by 18.2 plus 27 minus 34 squared divided by 34 plus 60 minus 55.1 squared divided by 55.1 plus 15 minus 13.0 squared divided by 13.0 and equals. And when you do all of that, you basically, what you should get is this chi-squared is equal to, and you do each one of these, okay? So you get the first one. I don't think we did it the same as in the book, but let's see. 21.952 plus 2.489 plus 18.776 plus 1.070 plus 0.000, which is weird. Which one was that? Oh, that must be this one. Plus 2.670 plus 29.358 plus 8.908 plus 6.856 plus 1.427 plus 0.438 plus 0.324 equals, and then you get this chi-square equaling 94.269, okay? And now we need to look up this chi-square under our chi-square chart, just like we did before, and see if it's relevant. Does it fall? Remember, we have this chi-square chart, and does it fall within this boundary? And so the next question is, does it fall within the boundary of 5% significance? So we look at 5% significance, and remember that's the chi sub 0.05, right? So, and is this a two-sided? Right? Is this, remember?
No.
Yes. Because our alternative is just, it's not less than or equal to. It's not it's not less than or equal to. It's just not equal to, right? So it's not less than or greater than. It's just not equal to. So therefore, we're not going to cut the alpha in half in this case. We're not going to cut the 5% in half. So we're going to look up, but we have to know what our not our expected frequencies.
I think you do cut it in half for a two-tail.
No. You cut it in half for a one-tailed.
Are you sure?
No,
Yeah.
I thought it was two-tailed that you cut in half.
Are you sure?
Yeah, because I thought it was two-tailed,
No.
like two sides. Where's my note? No.
I know, because I didn't cut it in half for the last one.
No. We don't cut this one in half. Remember, for the chi-squared, you cut it in half for the greater than or the less than, but you don't cut it in half for the other ones. For the null hypothesis ones, you do, because the two tails are two pieces. But for this one, for these, you don't. Okay? So in this one, you don't cut it in half. We're looking up, we want to find our critical value, and to find our DF, okay, our DF is equal to the rows minus 1 times the columns minus 1. Okay? And in this case, our rows have 3 pieces. So in this case, it's 3 minus 1 times, and our columns have 4 pieces, single, married, widow, divorce. So 4 minus 1. So we have 2 times 3, which is 6. So in this case, our DF is 6. So we're looking up 6 in the chi-squared chart. And in the chi-squared chart, under 0.05, 6 DF, we find that it's a value of 12.592. So where does 94 lie? Way over here, right?
Yeah.
So 94 is over here. So that means that we do not
Seven.
accept the null. Remember, if it's in here, we accept the null.
Mhm.
So in this case, we do not accept the null. Okay? And so on the test problem, which is problem 1272, it's going to be just like this problem. So go ahead and try it and use this. It'll be on YouTube.